Let's go silence. All right. Joe, you want to clap?
I feel like he's trying to encourage my disappointed face. That's what he's doing.
I did tell Vlados I would send him a clip.
You're listening to Coding Blocks, episode 89. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
Check us out at codingblocks.net. We can find show notes, examples, discussion, and a whole lot more.
Send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks, or head to www.codingblocks.net and find all our social links are at the top of the page. With that, I'm Alan Underwood.
I'm Jerzak.
And I'm Michael Outlaw. So, as always, we like to start off by saying thank you to everyone who left us a review. So, on iTunes, we have char broiled string cheese.
Yum.
Or would you say car broiled string cheese?
No.
Ooh.
No. Char. All right. And Narnor. I practiced this one before. Zhao Ying, 189, and Boot Manager. You think I got those right?
Yeah,
I hope I got it right.
Pretty good, man.
Yeah.
It's like the working out's paying off.
And hey, guess what?
Thank you.
I'm going to be at Atlanta, triumphant return. I haven't been back since I moved, so this is going to be the first time in Atlanta in a couple of years now. For Code Camp 2018, I'm doing a session there about search engines. So if you are in the Georgia area, you should come check it out. And I think all of us are going to be there, right?
Yeah, man.
All right, I'll be wearing shin guards.
Joe is the only one you're allowed to kick in the shins.
That's right. That is correct. I don't take kindly to that.
Yeah, if you can, I'm quicker than I look.
Awesome. All right. And then also, if you happen to be down in Orlando towards the end of September for Microsoft Ignite, I'll be there doing a session on Azure Functions and Cosmos DB and data pipelines and all that kind of stuff. So I don't know if that's closed or if there's going to be people in it, but come find me, say hi, and that's it. So we wanted to last episode, we talked quite a bit about various different complexities with Big O and that kind of stuff. And we went deep on it, but we wanted to circle back and just do almost like a Cliff Notes version of this thing, because it's something that a lot of people get intimidated by. And I think just having some of these quick and easy things that might help stick in your head, will take you a little bit further. So we wanted to circle back to that. And so I guess let's start off, right? Whenever you have random access to an item that's O of 1, that's basically when we were talking about like a hash table lookup or a key lookup or something where it can quickly get to that item.
Like an array access.
Right. No, or an index or an array, right? We go straight to item number 5 or something like that. So that's always going to be O sub 1 or O of 1. Sorry. Good Lord.
It always bothered me that hash tables were O of 1. And I've read it, I memorized it, but it just seemed weird to me to have this hash table with a hashing algorithm, which is, gets you close to array lookup speeds, but it's not. There's a lot of stuff kind of going on underneath the covers, but they say it basically washes out to O of 1. And I've seen in practice, like swapping stuff out for hash tables has been really fantastic, but it just hurts my soul to say that's O of 1.
Yeah, because we know that there's other operations going on, but they say they're insignificant in the grander scheme of things, right?
Yeah, and if you'd love to hear an episode on data structures, you should listen to it, because there's a lot of ones I've kind of forgotten about, like heaps in particular, like even talking about graphs recently and like how to implement them and stuff. Definitely some stuff I could use a refresher on. So if you want to hear that, let us know. We're thinking about it. Yep.
All right, who wants to take the next one?
List iterations are always O of n. Even for an array or a linked list, it doesn't really matter the implementation, but generally if you're kind of looping through all of your inputs, just kind of logically, you can think of that as being an order and operation.
Mike?
Yeah. So summarizing from what we said last time too, like if you see the same collection being iterated over in a nested loop, then you're in a O of n squared situation.
Yep, and the O log n, that was like the divide and conquer type algorithms, which is another one that I've always found really unintuitive. It's like the Monty Hall problem. Remember that one?
Oh, is that the one where it's like you get 3 doors?
Yeah, one has a car and 2 have goats.
Yeah.
Yeah, and you pick one door, and the host says, "Would you like to pick another door?" And you should always say yes because math.
Right.
Yeah. And I've written a little program. I'm like, there's no way this is right.
Right.
So,
something like it works out in the beginning where your odds of picking the correct door in the first are like 33% per door. And so you think that when he asks you, do you want to pick another door? You still think, well, it's still those 2 remaining doors will still be 33% each, right?
Mm-hmm.
But it's actually like 50% or something like that.
Yeah, I just never understood by choosing it. And I'm left out a crucial part where, like, you pick a door and he says, you know what? This other door that you didn't pick is a goat. Do you want to change your answer? And you should always change your answer. And that's because you went from 33 and now you're at 50. But it never made sense to me. It's like, wait, like, why is changing your answer? Like, okay, if it's 50% now, like, why is it 50%, to stay the same? Like, I don't get it.
Yeah. So going back real quick on this divide and conquer, right? That goes back to the episode where we talked about algorithms like the binary search and that kind of stuff, right? Like it's taking a well-known algorithm and being able to divvy up whatever the work is. So then going into the next one, the ON login, which we've mentioned many times, and Joe even said on the last episode, like one of the tricks in an interview is you'll get something that is an obvious n squared, and then you typically want to try and bring it down to this ON login. And the way that's typically done is you have a list iteration or some sort of enumerable iteration that's going to be O of n. And then if you have an inner thing, trying to use some sort of divide and conquer on that, and that will get you to ON log n.
Yep. And why do you drive on a parkway and park on a driveway? I mean, come on. Right, sorry for the weird tangents. I'm sick, guys. Leave me alone. The worst one is n factorial to keep adding loops to every time an item is added, which we kind of talked about the permutations example there. Then your O of n factorial territory, and good luck with that one.
Yeah, I mean, your computer's going to melt.
And you want to think that O of n factorial is just theoretical and it never happens, but you will get asked those types of questions and situations.
And again, going back to this interview thing, if you were interviewing with one of the big tech companies out there, be it a Microsoft, a Google, an Amazon, Oracle, any of these big companies, you will be asked, what is the time complexity on this? What is the space complexity on this? Can you improve the time complexity? Can you improve the space complexity? Why or why not? So being able to speak in this terminology will matter.
I think if you're trying to prep for one of those big places, one good thing you could do is probably spend an hour at Starbucks trying to think of what you don't want them to ask you, and then prep for that.
That's amazing. And cracking the coding interview, right?
Oh,
Pick that book up. Just do it.
Would you say that in regards to like interview type questions, that if you're given anything that's permutation based or combination based, that's where it's a trick that you got to watch out for the n factorial problems? Does that sound like a fair statement?
I think it more plays into what Joe likes. I think anytime that you see something like that, you need to step back and say, is there a mathematical approach to this? I think that's the first trick. And then the second one is just what you said, right? Like trying to get out of the crazy complexity. Because that's something that I've seen a lot, right?
Well, okay, let me rephrase it a different way. Let me rephrase my question in a different way. What I mean to say is, if you see a question that's given to you that's permutation or combination based, then the quote, like first, your easy way out, your first gut reaction might be to go down an n factorial path by mistake. and they're
Right.
trying to like set the trap, right? And to see if you catch it. Does that sound like a fair statement?
Yeah, I
Joe,
feel like if they're already talking about factorials in an interview, it's just like
Oh, they
I'm
won't.
already exhausted.
They're not going to tell you.
yeah, no, and so I will say from my experience in both sitting on these and being a part of these interviews is they'll set it and see how quickly you walk into it, but then they'll also back up typically and be like, could you do this better? And so they won't stomp on you the first time for doing it that way because it's the obvious way out, but then they'll see if you can think your way out of it, you know?
Yeah, and yeah, I don't think I've ever seen permutations come up in an interview, but I've heard of, with some of the Google sample problems, like you've got 20 million boxes and 30 billion red balls, and how many? Ugh. Yeah, can I get some freaking Fibonacci or something? Next.
I think I read they don't do that anymore, though.
Yeah.
They don't do those bizarre questions like how many golf balls would it take to fill up a school bus?
Yeah.
Right. Yep.
That's good. I don't know how you should interview, but I don't think it should be crazy problems that you're never going to encounter in the workplace.
Man, this is completely tangential, but I've always had the same thought. Like, I would almost rather get somebody in that seems to do decent in an interview, let them work for 30 days or something like that, and find out, like, what kind of chops does this person have? I've always felt like the interview it never hits it.
Yeah.
You know, you'll get some diamonds in the rough that you didn't expect. You'll get some that felt like geniuses that you also are like, wow, this dude just really doesn't cut it. Like, or gal, it's just, I don't know, man. I feel like interviewing software developers is a flawed process, and I really don't know a good answer to the problem.
Well, that's been our long running joke, or my long running joke about, like, you go through the process of the interview and with all the interview type questions, and then your first ticket is like, okay, we need this div moved 3 pixels to the left. What?
Is that
anything like this in the interview?
Is that in log in? What is that?
Depends on how you do it. If you do it right, you can do it in factorial.
There you go.
Annoying.
There you go. Annoying. Awesome.
Oh,
all right.
It's annoying.
So who's picking up the space versus time complexity here?
I can do that. Write my name here. So, we talked a lot about time, and I think that's definitely the most common, thing when people talk about Big O. They're almost always talking about time, but space does come up, and I was definitely caught flat-footed in an interview once where I solved the problem. I was, in the middle of patting myself in the back, and they're like, "Tell us about the space complexity." I'm like, hit the brakes. And I was just caught flat-footed. Like, I didn't know how to answer the question. I didn't have the language to really say it. Like, I could say, like, I'm creating a variable every time. I knew about the stack and the heap, but I didn't really know how to express what was going on easily in an interview. And I'm sure I just sounded like an idiot. So that was kind of a lesson for me. And I still don't know that I could really, give a concise answer. Like, I don't know how to really say, like, oh, the memory usage is n squared, but I guess it sounds like it kind of boils down to the same type of thing. Like, you can, I still don't know how to do it. I definitely wouldn't feel comfortable doing an interview.
Well, we have here in the notes that, as regards to like space complexity being about like where the data is going to be stored for this, and that, specifically there's 2 ways, the heap or the stack, but there's also the disk that we didn't write down here, because if you think back to some of our conversations around like, remember the SQL series that we did a while back, and we were talking about like path enumeration versus nested set models versus closure tables, things like that, right? Like, you can definitely get in. You can not. It doesn't have to be in memory, heap or stack, to when you have to worry about the space complexity of the output of your algorithm, right? So wherever you're writing that thing to for long-term storage can matter too. In the last episode, we actually referred to an example of flash memory, because, maybe if you're working on, like a Raspberry Pi kind of project or some kind of small hardware device, and you just have a little bit of flash memory, and you don't want to wear level it to bad, right? Like then you might have to worry about like how much you're writing to the disk, how often you're writing to that piece of flash.
It's funny you mentioned that too. Like, I know Aztec,
HTAG.
Aztec has mentioned it a few times. He kind of re-implemented some of the sorting algorithms when we were talking about it in it was a C or C++, and he was kind of talking about how he was making some small optimizations, and I think he was kind of like using registers judiciously and whatnot. And I thought it was kind of interesting because it's like that's never going to show up in any sort of big O for either the space complexity or time complexity, but it's something that makes a big impact on the final results when you test it.
That is very true. Just because you're talking in big O notation doesn't mean there's not some real either nasty stuff that could still be there or really good stuff that just isn't accounted for, right? These are approximations. It doesn't tell you the actual end performance.
Yeah, and I thought it was really interesting that they left out the disk because like that's so much of what I do on a daily basis. Like I throw something either on disk in some way, like to a database or some other sort of service or something that kind of caches something for me or stores it for me, and then I get it out later. And that is so much of the performance burden and like that network traffic or whatever, that is usually so much more of the performance problems that I see on a day-to-day basis. And it's just funny to kind of see that excluded here. And I don't know if that's an artifact of like this kind of being thousands of years old or whatever, or, if just computer science is just not really equipped to deal with that kind of external reliance.
So one of the things that we have here too is the problem with using the scope variables is those are stored in the stack, and you have a very finite amount of space in the stack, right? Which we put here, but that doesn't mean that the heap is infinite either, right? Like you're still tied to a certain number of resources in your heap as well, but it's just that it's typically orders of magnitude larger than what your stack is. So
yeah, and I looked it up for C#, 1 megabyte for the stack and 1.5 gigabyte for the 32-bit heap, and up to 128 for 64. And some of that is configurable. It doesn't like just allocate that out of the gate, but 1 megabyte is absolutely fixed in C#.
That's interesting. That's not a ton. I mean, never really thought about it, but yeah. And here's the thing: like we're talking about managed languages right now, like C#, Java, that kind of thing. It's been so long since I've done any C++. Do you deal with the heap and the stack in C++, or is it all stuff that you manage on your own?
Well, no, you still have to deal with it. I mean,
no, but is it still allocated separate?
If you create an object, then that's on the heap.
Okay. It's just that you have to manage it yourself instead of a framework managing your heap and your stack for you. Because there's garbage collection.
C# latest, or sorry, not C#, C++, like where are they on, like version 11 or something like that? Like I think it's come a long way in regards to garbage collection and memory management, if that's what you're referring to.
Yeah, that's what I was talking about. Okay, that's interesting. I mean, it's been a long time since I've done any C++ work. So
if I malloc something, is that intrinsically the heap?
That's a C operation. Not C++, but yeah, you'd be getting memory from the heap.
Okay. And my pointer is in the stack because it's going to live wherever the scope that I declared it.
Yes, but it's pointing to the heap.
Okay.
Yeah.
And yeah, my understanding of the kind of the stack, I mean, it's definitely rough. But basically, like whenever I call into a new function, like I've got any sort of pointers over to the heap, or I've got some value types that are kind of they've got their memory allocated there, and that kind of gets added on a frame to the stack. And so like I can go through in my stack trace, or I can kind of inspect that and see like all the memory that's been allocated for that particular function call. And if we go into like say an inner loop or something, then that's going to get its own stack entry or frame added to it. And then when that loop is over, it's going to clean up whatever is not needed anymore. It's going to pop that stuff off the stack. And when that function is finished, it gets popped off the stack until the program is done. When it gets back to that main method there, and it returns out of there, and then we're done.
And then your heap in a managed language gets cleaned up over time. So whereas your stack, like you said, as you get out of the function, gets cleared off immediately, right? So
Yeah, so it's really efficient in some ways because once your function is done, like any like value types or any pointers that like aren't, I mean, the pointers are going to definitely be cleaned up. Like everything that's in that stack frame is boom, gone.
Yep. So one of the things that we were mentioning about with the stack here though is you can run out, or even with the heap, right? You could actually run out of space before you run out of time, right? Like when we started talking about these n squared, n factorial type things, like, you might have all the time in the world. Your computer can sit there and churn away, but you're going to run out of space trying to allocate that stuff.
Ain't nobody got time for that. I went back and looked though. I referenced a moment ago the closure table conversation and nested set models, stuff like that. That was back in episodes 28 and 29 when we covered hierarchical data. And when we were talking about closure tables, we said that the worst case for closure table in terms of storage would be O of n squared.
That's a lot of storage.
Yeah.
But super fast, right? That was the thing about it, is it was incredibly fast. So,
yeah.
And like Outlaw said, we usually talk about the stack because the heap is generally really big and the heap is much, much bigger. And yeah, we mentioned, the stack trace is basically the call stack is the list of everything that's on your stack. But then, there's the infamous stack overflow, which is when you blow that stack, when you exceed the boundaries. That's if you have like an infinite loop or something, or like some sort of recursion that doesn't finish before it exceeds that, like in C# 1 megabyte boundary.
And that's the name of the website that we're all familiar with.
Yep. And what was our buddy John was saying, that Stack Overflow is like the number one cause of vulnerabilities still in software today, even though most modern languages don't even
buffer overflow.
Overflow.
Yeah, that's usually what they try to exploit, but it's a similar type thing.
Sorry about the confusion.
Stack overflow, buffer overflow,
buffer overrun. Yeah. So
yeah.
Close enough.
And I did want to mention tail recursion too, which is kind of like something you hear a lot about in kind of functional languages. And I was familiar because the Purple Wizard book, the Structures in Computer Programming. It was like how they used to teach computer science at MIT's like since the 60s. It's a book about Lisp. It's horrible. Lisp is horrible. Like if you pretend like Lisp, then I'm sorry to burst your bubble. Oh my gosh!
We will get one person that's gonna be like they were dogging on Lisp.
They know. Deep down, they know.
Is if you were to Google tail recursion and like the first thing for Stack Overflow comes up as a question is like, what is tail recursion? And they say, while starting to learn Lisp.
Yeah. That's like the first thing. Yeah, the book. It's an interesting book. It hits on recursion in chapter 1, and it just gets like harder and like crazier from there. I need to get back to that book, but I wanted to mention.
All right, go ahead.
Well, one thing that's kind of interesting about it is like theoretically, if you look at your stack, right, and you add a frame to the stack, and you can see all your pointers, you can see your value types on top of it. Well, what if you could tell that the current entry on the stack, I don't know, I can explain this very well, so it may not be worth trying. But essentially, if I can see that nothing that I'm adding to the next stack is used by my current function, I can see that the previous top entry on the stack has no bearing on the kind of the output, and all I care about is the new values on the function. So I'm not using anything in that old function. Then I don't need to just put something new on the stack. I can replace that top entry. So like an example would be if you're in a language that doesn't support tail recursion, you're doing something like the Fibonacci sequence, then you would do another function call. You're doing it recursively, the terrible way. You do another function call, you slop those variables up there on the stack, and every time you iterate, you're adding a new scope, a new frame to that stack over and over and over again. So if you're going to the 100th number, then you've got 100 frames added to that stack. But if you've got something with tail recursion and you write your function in such a way that it doesn't do anything after it returns, which is where I'm butchering it, but the idea is that the previous call doesn't rely on anything from your current call.
So it doesn't have to keep adding to the stack.
Yeah, I can just replace. So instead of adding 100 frames to the stack, it just says, oh, I don't care about the current one. Let me just blast it off, either pop it off or just replace the values in it. And so it keeps that call stack at essentially 1, which is amazing compared to n. So in memory complexity, it's amazing. It's, of order constant time with tail recursion for certain algorithms. And that's something that either your language supports or your language doesn't. And so it's kind of funny to think that your space complexity for an algorithm might change based on the language you're implementing it in, but that's the case.
Kind of makes sense, though.
The Stack Overflow answer that I was referring to says that the original answer was written in Python, but they later updated the examples to JavaScript because modern JavaScript interpreters support tail call optimization and Python interpreters don't.
I didn't know that about JavaScript.
But yeah, I had this funny thought though when you were talking about the list book though, I was like, well, what would be super awesome if they'd made this Easter egg, where see if you even caught onto it, where you read the first chapter and then in order to you start the second chapter, but then the second chapter requires that you reread the first chapter. Then you get to the third chapter and it requires that you reread the first 2 chapters, et cetera, et cetera.
Yeah. Well, joke's on them because nobody makes it to the third chapter of a tech book.
What? No one?
I'm kidding. No, a good portion of my tech books, I've only read say 1/3 of my favorite books, like the clean codes and clean architecture, stuff like that. Those definitely are cover to cover guys, but even design patterns, it's challenging to make it to the end, I'll say.
Yeah. I'm reading one of those challenging books right now.
Which one?
I'm afraid I hate to throw it under the bus since I just said that.
Yeah. But no, please. I mean, this is, we're all friends here.
It's a deep learning book.
And, okay.
And I mean, I like the topic, but the book, from reviews that I've read of other people, I thought maybe I was having an anomaly of why things I didn't like about it. And then I started reading some of the reviews. I'm like, oh, everybody's having the same problems that I'm having with it. But there were several that were like, hey, once you get past the first few chapters, it does get better. So I'm like, okay, I'm just going to power through and keep on. But
fair enough.
I think this is so common with the Gang of 4. That's why you see so many factories and not so many flyweights. So it comes in a later chapter.
Right.
Yeah.
It's probably true. As sad as it is, I guarantee you it's true.
Yeah. So how does Big O work for space complexity? It's basically the same. Big O doesn't care if you add 3 variables to the stack for every input because that's a constant, so you can drop it. It's much more concerned with the fact that you're adding things to the stack for every iteration, for example. So that would be, if you do it for every input, that's going to be order n operation.
Yep.
So to clarify though, it does, when you said if you're adding 3 variables to the stack for every input, that it would care about.
Well, that'd just be an O of n operation, right? It wouldn't be an O.
If you have if you pass in an array of 100 items, and for every one of those 100 items you add 3 variables to the stack for every one of those inputs, then you do care about those 3 variables in that case. It's the case where you don't care, where it becomes O of 1, is if you take in some array period, you add 3 variables, and then it doesn't matter what the size of that array is, those same 3 variables get added, period. Those are the variables you don't care about.
Yeah, we're kind of saying the same thing. What I mean is that example where you allocate 3 variables per iteration per item in that list. In that case, you're doing 3 allocations times n, so 3n, but we don't care that it's 3, so it's just order n.
It's
but
still
right,
order
1.
Yeah, it's weird, but when you go back to the Big O stuff, basically any kind, there's the constants, right? Or these, like that one, it's a factor of 3 on every n, but you throw that away. They don't care about it at all. So unless you were adding n number of items for every iteration of n, which would be n squared, then you just throw away that other factor. It does not come into play. And I know that's crazy, but that's what we were talking about earlier too, right? It doesn't matter that you do the same 20 operations on every iteration. It doesn't care. You throw them away.
Yep. So he said that I'm definitely not an expert at it. So I would love to hear your ideas or comments down in the comments section for the show notes. This will be at episode 89?
Yes.
Yep.
Episode 89. We're getting close to 100. We do anything special on 100?
Oh, we'd love to hear your ideas for what's for episode 100.
That could be scary. We do have a whiskey channel over in Slack.
That's right.
It'll be 2019 before we get there.
It will be 2019, but it's not too early to plan.
Yep. You got to do a drinking game. Sorry. I let the dog. I didn't close the dogs out of the room tonight. I'm sorry.
Who let the dogs in?
All right.
Well, I was going to go on, but now I've got Skook and Ducks.
Yeah, right.
What else should?
All right. Well, I'll do it this time then. If you haven't already, first off, the reviews for this particular episode were just amazing. Thank you for writing them. If you haven't had a chance yet and you'd like to give back to us, we mentioned it. We super appreciate it. We read them, puts a smile on our face. Go up to codingblocks.net/review, and there's links there to take you to the iTunes if that's your thing, or Stitcher. And if there's another place that you'd rather do it, please do. And also, as Mike said in the past as well, do share with a friend, right? Like if there's somebody that you want to improve their coding, then share it, and share it with other people who are interested and passionate about improving their skill set. So, thank you.
All right. So it's my favorite portion of the show. Survey says. All right. So last episode we asked, hey, how's your math? And your choices are, there's an app for that, or was great in primary school, or I can tip 20% comfortably, or I can still find the area under a curve, or I can still take the natural log of E with the best of them. All right, let's see. Alan, you go first.
Man, what's funny about this one is I want to say that I can tip 20% comfortably, but that is strictly a U.S. type thing. There are places in the world where they just don't tip. So I'm going to toss that one out, and I'm going to say there's an app for that, and I'll go with 37%.
All right, that's pretty good.
37.
You going 38? Oh, he's trying to block out his dog.
Yeah, it's a Royal Rumble behind me right now.
Just let it roll, man.
All right, I'm gonna go with 30%, 38% for whatever Alan said.
You don't even know what I said.
There's an app for that.
All right, so you're both going with there's an app for that. Alan at 37%, I think I heard, and Joe at 38%.
Yep.
Okay. And the winner is neither of you.
Really?
Really, guys? Like, you don't think our audience can tip?
That's true. That's true.
Wow.
Crap.
Wow, guys. Wow. Wow. That's all I got for you guys.
How high was it?
It was like 55% of the vote.
Dang, son.
Wow.
That's awesome.
Which one? Which one?
I can tip 20%.
All right. 50%. Okay. That's good. How many people could L in a V?
Oh, nobody can do that.
Nobody.
Yeah.
It was like 15%.
Yeah.
They lied, but
yeah, that's insane. What about the area under a curve?
Log of anything without thinking about it for a minute.
I don't even remember how to do it. I'd have to go look it back up again.
Natural log, wasn't that like a fraction?
Oh, so now you can't answer the question with a question. That's not how that works.
I don't know, man. I got a cold. I'm sick, and I can't even tie my shoes now. So
wait.
All right.
Natural log of E wasn't that an exponent to 1 over the exponent, or like it? See, that's the thing. This is where it drives me crazy. It's been so long
Oh
Yeah,
man, what you guys want to know the answer?
it's a
I do.
fraction.
It's 1.
What? It's instead of like a base 2 or base 10 or whatever, the base is like 2.7182818284459. Blah,
Pulled
blah.
that off the top of your head, did you?
I did. See, I knew it so well. No, of course I had to look that up. That's what I'm saying. Like, nobody can take the natural log or something without a calculator. Come on.
Dude, you want to know what's awesome here is there's a web page that showed up when I searched for it, demystifying the natural logarithm of ln. And I swear to you, it's like a novel. Like, is that really demystifying something? If you've got to read 20 pages, like, I don't know.
Yeah, I need like 20 tweets, guys.
Yeah, exactly. Keep it short.
Still too many. That's 19 too many.
I've thought about like trying to kind of like buy like a college textbook and like trying to kind of relearn my maths, but like ultimately I feel like I'm not going to use it, so it's just going to kind of be very pointless. But I would love to not, to kind of relearn some of that stuff, because I felt like I was pretty good with it for a while there. Like I felt like I was like the calculus kid in college.
Yeah, same here.
Yeah, I had a conversation with a friend of mine, with a friend of ours, actually recently, where it was like, yeah, I used to think that I liked math, and then I started reading, some of these equations, like the getting into like I can't even say it, Jacobian matrix and partial derivatives, and I'm like, wait, what? I don't remember what. What is this again?
You know what though? Don't you somewhat feel like the order of which you get your education is almost backwards? Because like after being a software programmer, you care a lot more about the things that you've already forgotten from school, right? But if you had been programming and you were in school, you'd be like, oh, that's amazing. I understand that. I know exactly how I can put that to use or whatever. And it feels like it's almost backwards, right? Like there should be more of a I don't know, like an apprenticeship type thing, right? Like where you work doing something and you're learning about that stuff as you go. I feel like it would be a much better way to do things.
Well, I've had a similar thought where I've kind of thought that it should be more the norm where you go back to school as an adult, because like, you've been the further away you've been from the school, even if you like us are still trying to like study topics and whatnot, right? It's still easy to lose sight of some of these things that are like fundamentals, quote fundamentals, depending on, what you're doing, right? And it might not be, if all you're doing is moving pixels around, moving the div 3 pixels to the left.
Yeah, I'll be like the only 40-year-old in stats class, stats 1.
Oh man.
Well, that would be nice. I would love to be better with that.
Yeah. All right. Well, this survey we ask, what's your preferred password manager? And what's your password?
1, 2.
The same combination as my luggage.
That's right.
All right. So your choices are 1Password, LastPass, KeyPass plus Dropbox, RoboForm, or Keychain, or I just use the same 3 passwords everywhere, or whatever is built into the browser.
Hey, and we will not be tracking logins for this. So if you are using the same 3 passwords, we won't know.
Yeah. Then you can just type away. Don't worry about it.
Oh, man.
See, if I had to guess for you, if I had to answer for you guys, Joe's probably the last same 3 everywhere. No, just kidding.
But that would mean typing it every time. I'm not doing
I have no online footprint, guys. I don't use password managers.
There you go. Facebook seppuku.
All right. Well, let's get back into Big O and talk about why it matters.
All right. So, one thing that I kind of we mentioned it several times is that like this isn't great for this or that, or when we're dealing with databases or distributed systems, or like when you have like multiple processors and stuff, like all those things, like something changes, it's like maybe you're willing to suffer some extra load if you can split that up in like a map reduce type way, or something that can be parallelized. And so I was just wondering if we had like a newer, more modern system for Big O. I don't know if you guys ran into anything that's kind of attempted to kind of bridge that gap in like computer science.
You mean as a way to measure, whether or not it's like O of n versus O of n squared, like something like that?
I mean, like a whole nother system. Like it's like, hey, yo, Big O was invented. Like, would you remember what year it was? It's like
1889 or something like that.
yeah. And so like you would think like by now, like there's all these PhD students who like every year they have to churn out papers on some topic, right? And everyone's always like trying to figure out what the topic and specialization would be. You think someone by now might say like, you know what, maybe we could come up with a better way to compare algorithms than Big O.
That's interesting.
Big theta.
Yeah. Let's see, better system.
Well, no, I think this is why though that I mean Big O, yes, the groundwork started back in like the late, what would that be, the late 19th century. But this is why we were, I was kind of jokingly brought it up the last episode where like the credit went to there was the and others, right? Because it's been an evolving concept, right, that mathematicians still add to, right? So I don't know that it's like, it's not like it's been static for the last 150 years.
I found a tilde notation.
Yeah, I was just looking at that. I've never heard of that before, but it does look like it attempts to kind of do some of the same things, but it seems like that's kind of more of a replacement for the actual notation, kind of like replacing the Big O and not so much the algorithmic analysis kind of side of things.
But you know what? Going back to what your whole thing was like dealing with distributed systems or parallel processing, if you think about it in terms of just what Big O was even meant to do, it's not like it changed because of the speed of computing, right? Like what you're suggesting almost is like when you throw in parallel processing and distributed systems so that you have multiple systems working on it, you haven't changed the time complexity of it. It's just the speed at which all the stuff gets brought back together or whatever. So, I mean, I don't know. It seems like it's held up pretty well, even thinking about that, right? Like you're still going to have a number of operations that happen on all your nodes, and then they're going to come back together. And then your constant time would be putting those things back together, and that's going to get thrown away anyway. So it seems like it still works.
It's kind of funny to think like, well, this operation takes much less operations, and so it's better. But this other one that we're getting away from runs in 10% of the time. I mean, it uses like 10 of our CPUs to do it, and it like practically kills a computer. But sometimes, that's okay.
Well, I mean, now we got things like quantum computing that are coming up, right? Like with the, what is it, the R language or whatever for .NET
Q.
And that kind of, or Q, that's what it was. Not R, yeah, R statistical. But yeah, so I mean, I wonder if that's going to change things. Like at that point, the quantum computing is just way faster, but it still takes a number of operations to do it, right? So I don't know. If this thing's been around for over 100 years, it's still just talking about, what are the orders of magnitude of processes that this has to do to finish its task.
Well, also keep in mind too that when this, I went back and found it. The date was 1894. So this predates anything about computers. So its origin has nothing to do with computers. We apply it to that field, but it's also used in other fields too.
That's a good point. Yeah.
Yep. Yeah. So I don't know what to do, but it does seem like there's like I wish I could like invent like a school of academia or some sort of I don't know, field of study where people are out there doing studies all the time about like how effective are unit tests really, and how do you compare algorithms in a cloudy distributed world. Yeah.
Oh,
like, would it be nice to be able to like go to the boss and say like, hey, unit tests in these 7 different trials, case studies involving companies just like ours, show improved performance to fix bugs of 17%.
You had a good thought that was similar to that last week, maybe related to picking frameworks. Remember that?
Oh yeah.
Like, if there was someone in the academia world did a research on like, how beneficial is it to switch from a Vue to a React or a React to an Angular or from a vanilla JS to an Angular, or, does it make the project actually better? Like, can you quantify that?
How would you
How do you
quantify that?
that?
It's
Like,
so
I want Big O
subjective.
for that.
Yeah,
what's
but
Big O of React compared to Angular?
But how would you do it though? Seriously, like you take the three of us, and React might click for me, Angular might click for Outlaw, and Vue might click for Joe, and it's just because how we think, right? So like going between the three different frameworks, probably it's not even a fair assessment, right? Like how would you say that? This one's better than the other one because you could probably make the argument that, hey, for this guy, it just made more sense to him for whatever his previous experience was. So I don't even know how you quantify stuff like that.
Well, maybe you take in Big O notation, how many steps does it take to create something basic? And then that would be a signal as to how likely you're to create a bug. Like the more code required is the more opportunity to make a mistake, right? So maybe that could be one input. And then like for common, additions or modifications that you might want to make, like adding a function, a feature, or modifying a feature, like things like that. Like how many operations does it take to make either of those things happen? Again, because you might the more steps you would take, the more likely you'd introduce a problem.
That'd be funny. Yeah, like number of lines written and number of files touched. Like,
yeah,
a file factor of 4.
And then like good practices too, like Angular is out of the box you get TypeScript support, right, with the latest Angular. So that's going to kind of put your guardrails on, if I could borrow a term from episode 1, related to making sure that the types are what you think they are in a JavaScript world, right? I don't know. I'm just thinking out loud.
Yeah, for sure. It'd be cool to see something like, even if it's like, I'd love to see like a white paper or something, if it exists, where somebody does some sort of like analysis like that and comes up with some numbers. And even if they say like, hey, this is not a great way to make a decision, but here's one way to, perform a mathematical comparison between two different frameworks.
Yeah, I like it. I mean, it's all about quantifying it. Yeah.
So we need to set up a Patreon here. And if you guys will donate, we will try to find some PhD students willing to do the kind of studies that we want to see, like buy their lunch.
Oh man. So we did ask the question though, like, why does it matter, right? Why does Big O matter? And somebody had something about cryptocurrency here.
Yeah. I think that we've seen that matters a lot when, especially as Bitcoin got bigger and bigger, they ended up having to fork and make some fundamental changes to their algorithms because it just didn't scale very well and not very big. And even the kind of problems that they're solving kind of for like proof of work and some cryptocurrencies and whatnot, like they know roughly how long it's going to take for computers to solve the problem because they know how much work needs to be done in terms of times and space. And that's how they use it to kind of gate certain operations, which is I think is interesting. So if you're working cryptocurrency, then you're probably very aware of different performance aspects, and I think probably cryptography too. Like if you're looking at either writing a new cryptographic algorithm or trying to crack something, then you're probably very aware of the efficiency of how you're doing that because you're dealing with like astronomical numbers, data sets.
Although maybe you want it to be slower or take more time. That's right. In that realm.
Yeah, it's kind of funny. I guess that's the deal with like kind of the old, I don't want to say old school, like normal, like factorial or factoring based cryptography, where you basically say, doing this operation to check if your private key, matches what I expect or whatever, to see if this is the private key for my or whatever, if the keys match an asymmetric, then that's going to be fast to check if it's correct, but it's going to be brutally slow to figure it out if you don't know it already.
Right.
And they need to prove that. Like you can't just say like, well, I tried it 3 times and it worked out pretty well.
Right. So one of the other things,
security.
Say again.
That's what we call good enough security. I tried it 3 times. Good enough.
So one of the other reasons you might need it, we've talked about interviewing. It's probably going to come up.
That's way up there on the list.
Yeah. I mean, in all honesty, the academic side of this is going to matter for interviewing with big companies. But, and I don't know that we have it here, I guess it kind of fits in one of the other bullet points. So it's just knowing internally, like looking at it and understanding what you're looking at in terms of the orders of magnitude, right? Like, oh man, I'm in an O of n sub squared type thing, right? This is really nasty. So it's just being able to kind of look at the pattern and understand that, oh yeah, I mean, mathematically that means this thing's going to go off the rails at some point. So I think it's worth knowing, just also for your day to day stuff as well.
I think it's pretty cool to think too. To like, if you know a little bit about Big O, then you know what it means to mathematically compare two things and come up with an objective basis for a comparison. So, like I was saying with the two frameworks, like it may not work out that great in practice, but it's one way to look at a problem and say, like, okay, let's see if we can kind of subdivide it, drop the things that don't matter so much as we scale, and compare the actual, like, the growth of something, the growth curve of a process or of a something, to see which one's better kind of objectively. So it's kind of a cool way to think about problems.
All right, who's got the next one? I think that's probably you, Joe.
All right, yeah, a little bit of game programming. I know like A star and whatnot comes up a lot, and so and like game logic trees or just decision trees, stuff like that. A lot of times you have to take shortcuts. You just can't go down every path. You have to prune your trees in order to limit the number of decisions that you're looking at. And so you've got a lot of times way more input than you could ever use. And so you need to be aware of the kind of problems that you're trying to solve and the amount of data that you got coming in, so that you can know when you need to take those shortcuts. And profiling is going to help, but it's like one of those things, like you could probably save a lot of time up front if you know ahead of time or recognize ahead of time that something you're doing is a polynomial time, and you just know that as the inputs, the pixels and the polygons counts increase, this isn't going to fly. And so you don't have to go back and fix that later or wait for the profiler. You can address it up front because you know that it's not going to happen.
Now, someone put in here machine learning and AI, but I'm curious as to why.
Yeah, so for me, it was the decision trees.
Okay.
Yeah. So I know that, like, sometimes our buddy John talks about, like, using breadth first search over depth first search, because a lot of times the answer that you're looking for is more likely to be found kind of closer to the point that you're starting at. So if you've got like an infinitely long tree, or a tree so long or so large that it might as well be infinite, then you may want to cut that off, like after a heuristic, like say, give it 1,000 runs and then give me your best answer. And so rather than kind of going down one potential tangent that whole time, you want to kind of stick closer to your root of the tree. And so, the idea there is just kind of that I think that you have to make those kind of decisions more often, probably in machine learning and AI, because a lot of times you probably have too much data. And so you have to look at like things like either heuristics or smarter algorithms in order to kind of cut down on the processing time or resources. Brings us to business programming. I think that Big O probably doesn't matter too much in business programming.
Yeah, I don't know about that one.
Yeah.
Yeah, I mean, it looks like the notes that we have here is like usually your bottleneck is in the data tier or the UI. So as long as you're using good data structures on, whatever your middle tier is, you should be fine. But I mean, I've definitely seen things. I mean, heck, I worked on an e-commerce platform one time where, they were doing like n squared or n cubed type operations that, I mean, yeah, you could fix it with some data structures, but, basically they had implemented patterns that looked like it was going to be a modular, easy way to do things, right? Like a consistent, easy to follow type thing. And it was fine when there were 100 products in the store or 1,000, but as soon as you got to 10 or 20 or 30,000, then all of a sudden you started really seeing problems, right? So I think at least in terms of my my perspective on this one is typically you don't notice it until you started growing. And then once you hit like, there's going to be a certain line that you go over, and all of a sudden you're going to spend a lot of time and effort trying to fix these big O type problems that you run into.
That's a really good point, especially with those more steep curves. Is that like, 0 customers is fine, 100 customers is fine, 1,000 customers is okay, 1,200 customers is terrible, right?
Right.
And so it could just kind of go off a cliff really quickly, and it's not going to scale linearly if you've got something that's got a sharper growth curve.
All right. What are you saying, Mike?
At the start of that, well, basically you were describing like the scale, which is what Joe was saying. But at the start of that description, though, can't remember exactly what the comment was that you made, but it made me think of something that we talked about before, where when you had to look at like optimizations, because I was kind of thinking like, well, okay, your business programming or your business tier, your business logic, that's where it's like more likely that you might write like a nested loop going over the same collection, right? Like that's where it's easy to get into like an O of n squared kind of operation, right? Excluding like cross joins in your data tier, but so it might be, you might have that problem in there, and depending on what the scale is, you might not ever notice it. Again, going back to everything's fast for small n, you might not never notice it until the scale gets to where, like you were describing. But I'm pretty sure we talked about in the past though, and maybe it was in like the How to Be a Programmer series or something like that, where it was talking about like, when it comes to debugging your application or increasing the performance of your application, like oftentimes, anything where the latency is at, that's where your problems are going to be. So reaching out across a network or reaching out to disk, like, those types of operations. And I'm pretty sure like Joe, I think, had pulled up like here's how, many seconds it takes. Does that sound familiar to you guys? You remember that conversation?
We were talking about the hardware. Yeah. Caches and how fast those were. First level cache, second level cache. Yeah.
Yeah. So it's easy to, like, in that business tier, you could easily get into bad situations and maybe not even recognize it. And when you do go to do your performance optimizations though, you might technically have an O of n squared in there, but because it's only ever working on a small n, it's not necessarily the thing that you would go after first in order to solve your performance problems, right?
Yeah.
Right. You never want to micro optimize. We've talked about this. I don't remember if we talked about it in the 12-factor app or in clean architecture. It was one of the two, but it was something about there needs to be at least 2x returns on performance if you're going to go after something, right? And here's the thing. Again, it's not necessarily that it's bad, but I guess going back to the whole question of, do you have to consider this in business level programming? And I think yes, because you'll revisit it at some point, right? Like we've made the comment before that it's not like Twitter or LinkedIn were built the way that they exist today, right? They were built, they hit some level of scale, and then they said, oh crap, we need to go back and we need to figure out how to make this faster because we didn't expect there to be 100 million messages per minute, right? So I guess just the short answer to it is yes, it matters for business programming. It's just at what point should you be spending time and resources on it?
I went back and found it. It was episode 45 where we were talking about it, and it was related to the caching conversations. And there was a GitHub link that we shared that was latency numbers every programmer should know, right? And we covered like the latency to L1 cache being half a nanosecond versus a round trip within the same data center would be 500,000 nanoseconds.
That's
right?
crazy.
To send a packet across the network, across the internet from California to Netherlands back to California was going to be 150 million nanoseconds, right? Like things like that. So like that's where when we talk about, that's where I was going with that is that when you talk about performance, in Big O, maybe it's not necessarily what you have to go after.
Right.
You get the biggest bang for buck out of, trying to make something more performant.
Yeah, I think the standard advice is basically use a profiler and try to figure out where your biggest bottlenecks are in your most common processes. I always hear that phrase, but like I don't really know. There's not like you can't go to the profiler store and get something. Like I know kind of a combination of tools like Visual Studio's got something. I know I've used like .peek a little bit to look at memory and stuff, but it's not like a super easy process where you just kind of hit a button and get like the magical answers to all your problems.
Right. So when should you look into your algorithms?
Yeah, I just kind of spitballed this. I thought like when things are running slow, but like if we're talking about bad algorithmic growth curves, then if things are running slow, then it's kind of already too late, or it's potentially about to drop off a cliff really quickly. But I'm not gonna look at it too early though. I'm not gonna spend a bunch of time when things are running great looking for things that might be bad when I get a billion users. And typically I'm more worried about other kinds of scale. So I think if you kind of have been doing this kind of thing for a little while, you've been programming for a while, you kind of get in a little bit of an intuitive sense when you're doing stuff to think like, okay, this is a problem area to watch out for. And so that's good. You step into a new job though, you're probably gonna have problems. Maybe there's someone else you can kind of lean on there that's going to be more familiar with those. Those hotspots are probably going to be. I also looked into, like hardware provisioning or predicting costs for like, like the cloud calculators and whatnot. They'll have some kind of tooling around that, but that's more to like a cloud kind of hosting environment level, not so much at your code.
Well, unless your code is awful and required like a massive CPU on a cloud environment, then you might care.
Well, I wonder how many programmers know, like, oh, my app has an average CPU load of 2% and an average memory footprint of X. Like, I wonder how often, like, especially web developers, like, how often do we look at that stuff?
I would venture to say not enough. And I would also venture to say that when things do get moved to the cloud and all of a sudden costs skyrocket, people do start looking at it, right? Because it's like, wait a second, why? So you did mention the profiling. There's also load testing, right? So
it's a good way to kind of flushing out some problems because like a lot of times like load testing will test comes like some of your most common processes like checking out or signing up a registration form or something like that. And so those will kind of like highlight the places to start looking. And what do you do about it? Safe refactoring. Should do an episode on that one day. Basically just refactoring, but safe refactoring is the act of like refactoring in such a way that it doesn't actually change anything. So that's actually not a good answer to this. You should refactor in such a way as you can like slice out those algorithms, kind of like isolate them and then work on them in isolation with nice, pretty tests.
I do like the next bullet that we have here, which is you examine your data structures. There's probably not much that'll give you more bang for your buck than just understanding the workings of various different data structures. So
yeah, like I should be using a tree here instead of a bunch of different lists, or I should be using a hash table, something like that. That's the most bang for the buck I've seen. And
your thoughts, Mike?
What was that?
What were your thoughts on it, Mike?
No, I was going to go on to, we already mentioned the profiling the app, but someone has here like looking for duplicated work.
Yeah, that's something I've seen when like messing around with profilers a little. Often, sometimes you'll see like the count of times that certain functions are called, and so you'll see like a function like get customers is called 82,000 times, and you'll kind of drill in a little bit like, why is this one call called so much more? And then you'll go see it and it's in a loop or something that doesn't need to be like. Sometimes you'll see like redundant work where like something could be pulled out to like outside of a loop rather than in it. And that's not directly related to Big O, but because that's one of those things that can be kind of a constant, but it could really save you a lot of work. And so that's one of the first things I look at when profiling is like, let me see the most common calls or the most CPU intensive calls.
And that's funny what you just said about that. It's one of those things that gets thrown out in Big O. It could be a super expensive call that just happens to be in a loop, but it's not taken into account for when you're talking about Big O notation. So if you were drawing it on a whiteboard, you'd never care about it. But when you look at the actual implementation of it, it can matter a lot.
Yep. You know what, that reminds me, one thing I see a lot of times is like back in the jQuery days, like it would be common to like, like loop over something and you would see like the $sign, pound, get the ID or something and like append HTML or something. It always bothered me to see that that $sign like basically getting that element from the DOM in that loop over and over again. And it's just easier to do it that way, but it always bothered me to see that.
Because it's an expensive lookup if it's not being cached by the library underneath the covers, right? So
yeah, but like now that I know a little bit more about development, like what really should have horrified me is just adding to the DOM over and over again, right? Like the lookup sucks, sure, but adding to the DOM, having it repaint between like every iteration in that loop, like that sucks even more.
Yeah, when you understand the painting of the DOM and the event loop, it's eye opening. And that's one of the tools in Chrome. If you ever, this should probably have been a tip, but if you ever like were to open up your profiler in Chrome or Firefox or any of those things and look at what happens when you do something on a page, and sometimes you'll see this, like it'll look like a waterfall, right? And you'll see all the things that are running when it's painting one thing on the screen or something, and you're like, how did this ever even work, right?
Yeah.
So anyways, all right, so we got the fun stuff here.
Yeah, I thought it'd be fun to play a little game of over under again. So once again, Alan and Ella have not seen the topics that I'm going to spring upon them right now.
Or have we?
Yeah, I mean, if you went to the second sheet in this spreadsheet, then you'll have seen my secrets.
Oops.
Oh man, are they right here?
Don't click it.
I'm not going to. I'm that guy that doesn't like to know what gifts I have. Like I want to open it and be surprised.
All right. Well, let's get to it. So first up, computer science, underrated, overrated, or rated?
Or fine, you mean?
Yeah,
Fine.
Over, under, fine, right?
Under, over, fine.
I think it's fine.
Fine.
Okay.
I'm saying fine.
I'm gonna say fine too, just because a lot of people hate on it nowadays.
I think it matters. It matters.
It definitely has its application. I mean, that's where like the more complicated, like I wouldn't consider, moving the div 3 pixels to the left as computer science, but concentrated areas of study like machine learning or AI, those kind of things, that's important work that needs to happen. We want self-driving cars to actually work, right?
Yep.
That's a really good point. Yeah, really good point. And yeah, I think like in, I don't know, like early 2000s, like Java ruled the roost and like computer science ruled the roost, and then like Ruby came out and they're like, no, screw that, HTML. And so like things kind of took a turn, and then JavaScript is now like the king, and like, yeah, so computer science is in the back seat right now, but I still think it's really important for certain applications.
Yep.
Design patterns.
Under.
Okay. Outlaw, what do you think?
I'm gonna go with Alan on underrated, because I don't think it gets talked about enough early on in your like education and career.
Oh yeah, that's good. Crap, you just changed my answer. Maybe.
So what's yours? You were. It was good.
I was gonna say good, because I do think sometimes it can be like overdone, but also I think that there's lots of times I've like looked at the system and been like, man, why didn't we just use like a common pattern that we have an ubiquitous term for? You reinvented the observer or whatever.
Yep.
All right, I'm switching to under. Underrated. I think that people should learn it sooner. Data structures.
You go this time, Mike.
I'm gonna say underrated.
Same.
Yeah.
Same. So far, we're the same on everything.
Man, this sucks.
The worst game I've ever
run.
All right, we're gonna have to get controversial.
Okay.
Node.
Ooh. Man.
Oh boy.
Here we go.
It's not over. I'm gonna say it's fine.
Fine. I'm gonna say. Shoot. So I'm gonna say fine. Fine.
Fine.
It's
Uh,
amazingly impressive what you can do with some Node.js. That's it. Like,
but all it is, it's just yeah. It's a JavaScript interpreter that's not within a browser, though, right? Like the only reason why we talk about it is just because there's like the one thing. I don't know. It's not.
dude,
I don't.
it's a web server. It's a dude. Go look up an npm package for anything that you want to do, and it probably exists, no matter how weird and
NPM.
Itself
obscure.
is not a web server. It's just that code was written to use it as the run as the interpreter to make a web server.
That's what I'm saying, man.
An interpreter, though.
Right, right. Express.js was written on Node.js. Like, I'm just saying, like the fact that you could basically with and man, what's
You could write a web server in any other language, though, but yet you're not as excited about that as you are about writing it with Node.
the
That's why I'm
ecosystem?
saying it's overrated.
The ecosystem around Node has made Node impressive.
Yeah, that's
Okay,
kind of not
were
fair
you
though, right?
excited about Perl back in like the 90s because of CPAN? You're like, oh man, the ecosystem around Perl is amazing.
Man, I mean,
Well, they weren't
just
using it for the Perl, that's for dang sure.
I mean, just saying, man. Like, what else have you seen spring up and so much come out of so fast
Java.
as Node.js? No, no, not even Java,
What?
dude.
Java's king
Node.js,
for a while.
Java was king, but Node.js blew up when it came onto the scene. Like, just straight up blew up, and it hasn't gone anywhere in like a decade or however long it's been around now.
Has it
So,
even been that long? I mean, Java's been a thing since like the mid 90s.
Yeah,
Like,
but when's the last cool like idea you heard come out of Java? Like a lot of stuff did come out of Java, like even like fluent syntax, like all sorts of cool stuff and like annotations, like a lot of like so much innovation was there in like the early 2000s. But then like all the innovators left and went to Ruby, and then
or C sharp.
6 months later they went to Node.
Yeah, I don't know, man. I think it's just fine for that reason. Like, it's an impressive ecosystem built around it.
I'm not saying that. Don't take my saying
No,
it's
no, yeah, yeah.
overrated as
No.
saying Node itself
Yeah,
isn't a good
Right,
thing,
right.
or that it's
You just think it's overhyped at this point.
yes, it's overhyped. Just
Yeah.
like I used to think that Java was overhyped too. I mean, even though I reference Java as like bringing up so much, but because I remember this was the one that bugged me so much was back in the 90s. I don't know if you guys remember this, but IBM used to run a commercial where I forget it was, but at one point during the commercial, you would hear this guy say, Java, well, you got to have Java. And I'm like, really? Why are you talking about any programming language on a commercial?
Like, it matters.
Like, who cares? Like that's it became a marketing thing. And that's where I was like, okay, it was overhyped. Right.
I mean, Node.js is just the
Got in
engine.
there maybe, but
I don't know. Yeah. All right, what we got next? What we got?
JavaScript.
Oh, it's fine.
Yeah.
Outlaws, he's struggling.
yeah. Can I do my Picard? Like, oh
Yeah.
God. I guess I'm going to say fine.
So Node overrated, but JavaScript fine.
I mean, it's so necessary though to do any kind of decent web applications these days.
Mm-hmm.
What about you, Joe? Where'd you land on this?
I feel like
Yeah, it's tough. I'm going to go with fine because of ES6. If it wasn't for ES6 and some of the, like the nicer stuff that they've added, then I would definitely say over. So consider yourself warned, JavaScript. You're on the edge.
Well, now they're iterating on it fast though.
Yeah, ES 2017 is already a thing.
Yeah.
Yeah,
So I like your explanation. I'll buy that. Yeah.
Yeah.
all right. So we're all fine with that. ORMs.
Ooh. Outlaw. Actually, Joe, you go first this time.
Nothing.
I don't know. I guess I'm going to just have to say fine because I don't know.
I'm going to say underrated.
All right.
Oh, that's interesting. I think I'll go fine, although I'd probably lean towards underrated on it as well.
My reason for the underrated though is because it's so easy to just write your query, pass it off to some kind of database system that can execute it, like whatever library you're using, without having a true ORM there and just getting back like a data table. And like, so you end up with all these like one-offs, and your code is just very intimately aware of what's coming back from that exact query, and it's that you're too coupled to those queries. Yeah. So that's why I was going with that.
Yeah, I agree. I like the explanation. I'll stay with fine.
All right. What about code comments?
Overrated.
Yes. Overrated.
I think they're fine because I do some nasty stuff, and I like to excuse myself. I like to get that moral license. Like, I did some nasty stuff, but there's comment about it, so you can't hate on me.
Here's my reason for the overrated is because it's too easy to rely on, hey, I'll just write bad code and then I'll explain it with a comment and I've covered my butt, right?
Yeah, that's what I like about it.
Whereas if you were able to take the time to make the code more expressive to where you didn't need it, right, then that would be a much better approach. Now, there are situations where a comment might be necessary, and I'm not saying that there aren't times. I'm not saying that there's never a time to comment. I'm just saying that it's too easy to fall into the bad habit of relying on them.
I have a different reason for it, but it's along the same things. Mine is people don't ever change the comments. So if you ever do refactor the code, the comment stays there, and then people are misled. And that's why I think they're overrated. Like I'd rather the code be more expressive.
There was something similar that came up in the Slack channel. I want to say that Mike brought it up, where we were talking about we were talking about commented code being in your code base, right? And he'd shared like a regex to find.
Oh yeah, like 5 lines.
Yeah, some X number of lines of commented out code that might be code that you want to delete. And some of the conversation was about like same as with the comments though, is that, hey, you refactor something, you change something, and now there's this commented out code and you're not sure like, what is that about? Do I just delete that? Why is that left there? Should I delete it? Or was it left there for a reason? Like maybe they didn't finish it. And so I should also make my change. Like maybe I changed the name of a variable or whatever, because if you were using a tool to do the refactoring, like to rename a variable, for example, or a class, it might not catch the comment, because it's a string, right? So it could be left alone. And then when somebody goes to uncomment that code, you're like, okay, I'm ready to start working on this thing again. And now it doesn't work.
That's a good point. Yeah, I don't know. I guess I just use it to make up for my bad code all the time. But there's a lot of times, especially in the UI stuff, where I have to do something weird because something weird is happening. I can't afford the time to refactor the world. So I'll kind of put a comment here. It says like, hey, you see the text defined here, but it gets changed dynamically in certain cases. Go check out the, whatever this file, because this value that looks like a plain simple thing is not what it appears. And I do the same thing in SQL sometimes, where I'll kind of put like not a typo. Like if there's something that just looks wrong, or like if two things are joined where it doesn't look like they should be, or I'm just doing something weird for some weirdo reason, and I can't afford to, or it doesn't make sense to change the schema, I'll put a comment in that says like, yeah, I know what this looks like, but it's actually good because see this ticket.
Yeah, I mean, that makes sense. I'm not going to hate on it, but
yeah, you're right there. I mean, everything says still stands.
Yeah.
All right, I got 2 more.
Okay.
Linux servers.
Mike?
That's a toughie. Because I want to say fine, but Windows has been getting so much better now. And now that you could run Linux on top of Windows, I almost want to say like, oh, then you get the best of both worlds.
Yep.
I'll say fine.
I think I'm going to stick with fine.
Yeah, I'm gonna go with fine too, but I feel the same way. I felt like Windows is catching up, and that's kind of why I wanted to call that out. It's like that used to be a foregone conclusion. Be like, yeah, I mean, if you can deploy to Linux, yeah, of course. But now it's kind of like, well, yeah, I mean, that's cool. It's kind of funny. Like now Microsoft's embraced, and like now you can actually deploy to Linux, and it's like, oh, actually, like I'm okay with Windows now.
Right.
All these years later, I don't care anymore.
Yeah.
It's basically what it is.
Yeah.
Well, it used to be a thing too that like everybody would say like, well, why would you even want like a UI on your server? Right, like that was a common argument back in the day. But in modern versions of Windows Server, you get asked. That's one of the questions. Like, hey, do you need the UI?
Yeah, you want to run headless? All right, we can do that.
Yeah, what's the new Pico or whatever? I think it's Pico.
They changed it. Now it's just Windows Server Core, right? I think is what they call it or something like that.
Oh, yeah, that sounds pretty cool. But yeah, I think with Docker and stuff like that, I kind of don't really care about the underlying OS anymore. Like especially with like cloud and everything, I just don't really think too much about whether I'm running on Red Hat or CentOS or whatever. Like it's kind of commoditized the operating system.
Yep. So what we got last year?
Last one. Fine. Yeah, I wanted to say for programmers. So from a programming perspective, Windows on the desktop.
Wait, like using the Windows operating system?
Yeah. There's people that prefer it. There's people that definitely don't prefer it.
Oh, there's people that it's either Mac or there's people. This is a flame war. I think it's fine. I like it. I mean, it depends. I guess it really depends on what you're coding in, right? But to Mike's point a minute ago, especially with the Windows subsystem for Linux now, or Linux subsystem for Windows. I don't remember what it's called. But that kind of is a game changer. So I'd almost lean towards underrated to a certain degree.
Yeah.
So the question is, do I think that using Windows as the operating system for my computer, is it overrated, underrated, or fine?
Yep.
I got to stick with fine.
Yeah. I think a couple of years ago, I would have said it's overrated because, on the Mac, I've got the terminal, I've got the bash, I've got brew, like I've got all these really nice tools. So I've got Docker. Now I feel like Docker's kind of even that score for me too. And so Windows is kind of like, it's convenient, but there's a lot of stuff I don't care about. And so, it's like Cortana and there's just a lot of stuff I don't really care about. And so in a way, it's kind of become commoditized to me too, but I still don't want to be I don't want to be living on a Linux box. Like I think it's cool. It's neat. But I don't want to have to be vimming into things all the time to change this or that. I like the Windows, so I'm going to go with fine too.
Yeah, I mean, my reason for picking for saying that it was fine was just because the variety of tools. I mean, you mentioned the Windows subsystem for Linux, but not only that though, like Git Bash, for example. If you ever use that, I mean. I'm actually trying to break the habit out of using Bash on Windows because in one form or another, like back in like the Cygwin days from long past, right? Like I've had this habit of using Bash on Windows, and I'm actually trying to like get myself out of that world, right? Because I kind of feel like it's a crutch almost to keep using it. As weird as it sounds to say, so like I feel like you can kind of have your cake and eat it too on the Windows world because there are so many. Just a plethora of applications out there and software that you could use on it, right? Where it's not like, definitely in like a Mac and Linux world, you might find yourself a little bit more constrained, especially like maybe not in when you stay mainstream kind of software, vertical, but when you start to get out into like the fringe edges of software, then you might find yourself more limited, right? So, yeah, I don't know. I'm going to say fine.
Cool. All right, cool. Well, I totaled up, and today I was actually the most optimistic with 2 unders and the rest fine. I didn't say anything was overrated.
Nice.
Yeah.
You are sick. You are sick.
So yeah, it's the cold medicine. Whatever. It's a NyQuil. So Outlaw, you had 2 overrateds. Alan, you had 1, and everything else is pretty close to the same. Outlaw, you did have more underrated. So you have more issue with how people think about these topics. And Alan, you and I are both pretty close on thinking that they're pretty close to rated as they should be.
Middle of the road.
Yep.
Wait, but you had 2 underrateds, right? And you said that meant that you were the most optimistic. But if I have 4 underrateds, doesn't that make me even more optimistic?
Oh yeah, I guess depending on, you had 3 underrateds. Yeah, so I guess you could argue it that way. But you did have 2 overrated, so I guess it depends on how you add it up. I don't know how to compare these things mathematically.
Right.
He's the curmudgeonly happy guy. Like that's
However that works.
right.
Get off my lawn, but look at how green it is.
Right. Come back here and swim in the pool, but don't touch my lawn.
Yep.
All right. Well, hey, I had a thought that I wanted to share with you guys though. We talk about we talked a lot about the clean code series, right? We've talked a lot about like some of the practices that Uncle Bob has put out there. And I kind of had this thought where it's like, sometimes, do you ever find yourself struggling with like the concepts of clean code, in that you'll want your function, for example, let's just say you're focusing on a single function. Like you want that thing to be small, right? But ultimately there's things inside of that you might need to do to make it complete. But if you were to break that out into a separate function, then some other developer might come behind you and be tempted to use it. And it's not something that you want them to use, right?
Mm.
Something that you think like, this is already probably a bad thing.
Mm-hmm.
Does that make any sense?
Oh, totally.
Yeah.
So I was curious to see, like, if you guys, like if you found yourselves at times like struggling is going to sound like, worse than it probably is, but you struggle with that kind of thing.
I do all the time. Definitely, it's a constant struggle, especially with those long methods. Like, in a perfect world, like we talked about, like the rule of 5, where it's like every function is small, every file is small, every namespace is small. But when you're in real world code, like sometimes you're in really big methods, and you don't even want to break necessarily your method apart, because it's going to get lost in this like sea of trash, right? So I do like C# now supports anonymous methods like inside the actual function, and I think that's one way of kind of doing what you're saying, because I have the same struggles a lot of times. Like I will do stuff that I hate doing, like modifying arguments or like modifying the internal state of like an array or a list or something that I pass into a function, and I'm doing that because I want the convenience of not having to duplicate code a bunch of times. I want to be able to reuse this common logic, but I'm absolutely modifying the argument, which is, I always think of as being a big no-no. And making it a private function isn't enough, because sometimes I've got some big class that I'm dealing with and I can't afford the time to rip it all apart. So I like the idea of doing little small anonymous functions, because it's kind of like a way of saying like, hey, this is mine in my function, leave me alone.
Yeah, I mean, I'm sort of in the same boat. I don't think I view anonymous functions that way. I don't typically do it that way. It's kind of an interesting take on it, but I feel like it's still all kind of embedded in your other functions. So you haven't broken it up that much,
Yep.
but at least it does keep it scoped to where people can't mess with it. But I have the same problems, right? Like I'll look at something and be like, oh man, like I think the one thing from the Clean Code series that stuck with me the absolute most is I want people to be able to read what's happening in my method like it's a story, right? Like
Keeping things at the same abstraction level.
not as much that, even though it kind of tends to just happen that way, but like if you can read it like a story, like, okay, go get customer. All right, update customer. Now get customer orders. Now do this with customer orders, right? Like if I can make it to where I name my methods and I put those methods inside the other method in a way that reads like a story, that's what I find myself trying to do the most. Where I typically end up struggling though with that is not, I don't typically think about, hey, what's another person going to come do after this, because I can't control them, right? Like some people are just going to screw up code no matter what you do. But the thing that I struggle with that always frustrates me goes to like the CQRS type things, the command query separation. it always drives me crazy that if I'm going to do something that mutates the state of it, then I got to go get the state of it right afterwards, right? And that always drives me kind of crazy. So I'll sort of struggle with things like that. Like, man, do I really want to split this into 2 or 3 calls, even though I know that it's all going to be done right there?
Yeah. And especially in JavaScript, like a lot of times I'll get some like JSON from the server and I want to augment that JSON. I want to format it. I want to, format the dates. I want this to be capitalized. I want to do some basic transformation on that stuff. And with JSON, it's so easy to just kind of like take that stuff and augment it right there. And I know what I should do is basically clone the object first and then make my modifications there and return that as a new object so I'm not mutating it. But like, come on.
Nobody got time for that.
Yeah. That's like JSON. It's already designed for that sort of thing.
You mentioned wanting your code to read like a story, but it made me think like, well, what happens if the story is the site of the crash?
Yeah.
Or everywhere. You're like, well, technically it's a story. No, it's going to be a story you enjoy. It could be like a Stephen King story and you just turn to the wrong chapter.
That's awesome.
But it kind of, I do feel a little bit better though, because definitely with some of the comments that you made, Joe, was kind of in the same thinking that where I've done this, where although I wasn't thinking of necessarily anonymous functions, but I don't know if I would call it a habit, but I have definitely found myself more in recent, year or two using functions. Like I'll create as a variable within a method, right? And then that way I can put an expressive name on whatever the logic is that I want to use. But like, as Alan pointed out, the scope of it is limited to my function. So no other developer can use that. And then when I find that there is a need to move that thing up to like, to make it more exposed, then I can, which is kind of like where I think we talked about it. Maybe it was with the clean code series, probably like, where defining your methods as private initially, and then progressively making them more exposed as you find a need, right? And I find like this is like a more granular, version of that, right? Where like now the scope is just within the method. And
it's like a closure, basically, is what you're doing.
Yeah. And so, I've kind of, every time I've done it though, I kind of catch myself and I'm like, on the one hand, I love it because no one else can use this thing. And I'm not necessarily introducing something bad to the rest of this class, for example. But on the other hand, I'm like, well, how bad of a pattern is this? Like,
Yeah. I don't have any like crazy passionate opinion about it. I get why you do it, right? And it's like you said, you lock it down. Nobody else can touch it. But then you are junking up that particular method, right, that you're in, because you're still going to have to organize it in a way to where it reads pretty and all that kind of stuff. Because, in the best case scenario, you're going to have a bunch of anonymous method or even variable assigned methods up at the top of your method that you're running. And then it's going to be down at the bottom where you're calling all that stuff. So it's still not pretty,
Well, that kind of like begs the question too, though, because there's, a lot of rule of thumb is to define your methods as close to where they're being used, right?
It doesn't get much closer, does it?
Define your variable as close to where it's being used. So, you could make the case that actually your function is going to be defined right before you call it for the first time.
But that'll suck too, because then it doesn't read like a story. Now you got a bunch of broken up code and blocks that's going to be hard to follow.
And this is why I bring it up. Right. Yeah. Exactly.
The struggle is real.
It is. Yeah. I would be ashamed to admit how much time I spend on trying to name things at times.
Yeah, that's good. I hate how many times I go into my code and I wish I'd named something better, because I'm like, damn, this is item and this is item and this is. I don't do single letters, but like I tend to name like a variable for something like, I don't really care too much because I only use it 3 lines. I get confused. I'm like, wait, which one was this again?
Hey, as long as you don't start your variable name with I underscore or S underscore, I'll be fine with it. Just don't do that to me. It makes bile rise in me.
Oh, Hungarian notation? You're not a fan?
I'm not a fan. I'm an anti-fan of Hungarian notation.
I did like one thing you said out loud too about like naming kind of like internal variables in your function like after what it is. So rather than doing something like doing an operation on .count, you maybe set a variable equal to that .count or .where .count or whatever. If you do something link, it kind of gives a descriptive name. So it might be like bad customer count or something like that, and because that's easier to read than seeing some big long link expression that ends with a count or a link than doing some sort of math on it or something. So it is nice to kind of see that intent there with a variable.
Yep.
Yeah, like a prime example. Actually, it came up. I don't remember if it was today or yesterday, but you might find yourself in a situation where you write an if statement, and you're like, if this thing is true and that thing is true, if both of these conditions, right? And so, I was like, to make this more clear, I'm just going to create a variable that holds a function that it states exactly why I need that condition to be true. So it'd be like, and then that way, when you read the if statement, it read better. But I was like, well, I don't need this anywhere else. There's no reason to pollute the rest of the class space for it. But yet, and if I did, like, why do I need anyone else using it? I don't feel like anyone else wants to use or should be using that. Maybe they should. I don't know.
Yeah, I still catch myself doing that.
I have the class doing too much, and that's why it's already a problem. And
I'll do some
argue that.
Did you just yak on the mic?
I'm yakking myself for talking over you. Sorry about that. But I get so excited thinking about the code. I was thinking out of the big if statement, I'll do like something like if initialized or if object equals null and needs is not needs initialization or something like that, and I'll put a little comment above it like if we don't have the object but we need it, and like what I should be doing there instead is using a variable. And sometimes I catch myself doing that and do the right thing and be like, oh, let me just create a variable that expresses my intent here, and then my if is super simple and everyone knows what I'm doing. I don't need a comment, but I still find spaces where I just kind of instinctively do those comments.
Yeah.
All right, so how about this one for you? This is going to be a C# specific, maybe, unless you can figure out a way to bring it into another language. But how do you feel about the use of the dynamic keyword?
It like kind of like defeats a lot of the compiling purpose, so it kind of bothers me a little bit. But at the same time, there's a lot of stuff I do that's like I kind of define my data output in my, like, say, SQL query, and my C# is just pass through. It doesn't make any decisions. It doesn't care. And so it's just a burden to keep that thing up to date. And so I like dynamic for those cases, even though I know Uncle Bob does not.
Yeah. I mean, I have neither love nor hate for it. I mean, it's a tool, right? Like if there's
like that, you're a derogatory term, like, oh, you're such a tool.
No, like it has its uses. Like if you're taking in inputs from systems, like, I mean, if you look at log formats for, I mean, I work with Splunk on occasion and stuff like that, and it takes in unstructured log files. And if you're taking in something like that, the dynamic's a perfect example of where using something like that works out. You don't know the properties and things that are going to be on it. That makes sense, right? And even like what Joe said, you have something that's going to be shaping your data, and you don't want to have a one-off DTO for every single different shape of that data that you're going to have for your possible results. I get it. It's a tool like anything else, right? Just like reflection, you'll have people that hate it. There's a reason for it, there are situations where it makes sense, and yeah.
Right. So, okay. So it moves. So one of the complaints that I heard Joe say was that you're moving the problem, instead of it being a compile time check, it moves it to being a runtime check.
Wait, is it even a check?
Well, that's what I mean. Like, error. It could throw an error, right? Like, right. So instead of finding your errors at compile time, that check happens at runtime, and it could error then, right?
I have very bad dogs tonight. Sorry.
That's awesome.
I think it's hilarious. But then the example that Joe gave, though, right, where like your middle easy for me to say, your middle tier was just simply passing the request through and then the response back through it, right? Like, and that's why you didn't want to have to care about it. But now, couldn't you argue that you're more tightly coupling the UI tier to that data tier? Because now, you know, the in order for the UI tier to know what what data came back, it knows exactly what the data tier sent. And in order for the data tier to know how to execute, what query, what you're ultimately trying to query, right? It knows exactly what the UI layer sent. There's no layer of abstraction between them.
It's true.
Yeah, maybe that's okay. Sometimes.
I mean, it's funny, like where I see that it could be extremely useful is in situations where you're doing like custom aggregations on data and stuff, and you're not going to, there's no standard way of saying, hey, count of this field or something like that, right? I could totally see where like having a dynamic variable there makes a lot of sense. Where I kind of don't like it though is there's no contract, right? Like if you have a request to an endpoint to an API or something, there's nothing there that locks you down to, hey, what's the contract that you're looking for? There's no way for you as a developer to go find it. You just have to know what it is. And I think that's probably the one thing that does bug me is if it's something that's a pass through, fine, I get it. If it's something that you've actually got to use, like you have your UI making a request to something, what am I supposed to pass to you? How am I supposed to figure that out? You know what I mean?
Yeah. Sometimes you don't care. Like I remember I wrote a thing for like sending some like syslog events or whatever, and it would take in like a query and it would serialize it to syslog format and spit it out. And like whatever columns you had in that query is what I was going to send to syslog. And so it was up to whoever was writing that query or whoever was like generating that query to generate what it had. And that made sense because my code's job was just a simple transport. It's like, I don't really care what's in here. I don't have any rules or anything per se. Like my only job is to get this from point A to point B. And so I think that was a good use of dynamic there because it had no sort of ownership. There's nothing to buffer. Like the UI or like the 2 points both already had that contract.
Yeah. So I guess the best would say is it would definitely allow us to be lazy.
Definitely.
And it would definitely break everything that we learned from like a clean architecture and onion architecture kind of approach, right?
Yeah, I would agree, depending on the usage of it, for sure.
Yeah, I like it.
So use
fine. Yeah, so, I mean, if I went somewhere and like saw like a whole web service tier that was all built around dynamic, I'd be like, oh man.
Right.
But what if maybe it's okay if the method that's using the dynamic only has like, 2 lines in it, right? Then that's where, to Alan's point about the DTO, it's like, well, why are you going to spin up a DTO just for this? Like, there's 2 lines of code and only one of them is using this thing that's passed in, right? Maybe.
I hate creating new classes, so I'm with you there. But now that we got named tuples in C#, I'm more prone to it.
Yeah.
Yeah.
I hate creating a new class. It's like, well, let me find some name to name these 3 properties, like as opposed to this thing that has these 6.
It is, right?
The naming is going to take like all day long.
It's like the name of this class is whatever damn data I need for this method.
Should we create tickets in our ticketing system for naming things?
Dude,
3 hours naming this variable.
No. That's right. The ticket itself was only 4 hours, but 3 hours of that was naming it. So,
hey, every pull request, you need to kick back with at least 3 name change recommendations.
Oh man!
Oh, yeah. That would actually be an awesome thing for a pull request, like, or for a pull a review of pull requests. It's like, hey, you got to at least like make some kind of recommendation.
Yeah, it's always you got
recommendations, or else you didn't really review it.
Yeah, that's awesome.
Yeah, I'm not doing any more pull requests. Thanks, guys.
Yeah.
Merge to master.
That's right. Done. Cool. All right. So we've kind of gone back over stuff, went on a bunch of tangents, and hopefully you guys got something fun out of that. The The resource we like is the Imposter's Handbook, which we can't recommend enough. It's awesome. And for a list of other resources, like we're trying to compile a good list of things that we highly recommend on codeblocks.net/resources. You can check that out. We've got a link to this book up there and like little brief summaries of all that stuff. So, check it out.
We highly recommend you use the term. Check it out.
Check it out.
All right. So with that, let's get into Alan's favorite portion of the show. It's the tip of the week.
Yeah, baby.
All right. So I couldn't remember if we've already talked about this, but Angry Zoot, Jessica, in our Slack channel, she mentioned this tip where if you copy something into your clipboard, and let's say it's XML or JSON, then Visual Studio will give you some really cool options if you go to the Edit Paste Special menu. So you could paste that JSON as a class or classes, or the XML as classes. So pretty cool tip. Thought we'd share it. I couldn't remember if we already did. So if we did, then I apologize that you're getting a repeat tip.
I did a long time ago, and I don't remember when. This has been a long time ago.
I thought you did, and I went back looking for it, and I was like, I can't find it, so I guess it never happened.
I don't remember where it was. Copy and paste XML into it. It was in episode 31.
No.
So it was like 5 years ago.
But Angry Zoot, you could have all the thunder then. That's fine. All right. So mine, I'm taking from somebody as well. So Dance to Die over in Slack, he shared that one of our previous Slackers, is it Slack? Yeah, it is Slack. Swix, he actually has a TypeScript for React cheat sheet, which is really cool. So we'll have a link to that there, because if you try and get started on TypeScript with React, there are some challenges there, and he's got some nice stuff in his GitHub page. So I checked that out. And then the other thing that I wanted to bring up, because it's new, I think as of SQL Server 2012 maybe, there is a format function in SQL Server. A lot of times you'll see people still doing like old school, like say that one of the things that I used to see is if somebody needed a number that was left padded with zeros, then you would let's say that you need a 6-digit number, then you would basically do a left string of 6 zeros and then concatenate the value that you wanted in it and then do a right 6 on it, right? You can do that now without jumping through hoops. The format function in SQL Server is essentially using the .NET format function under the covers. So just about anything that you can do with a format call, like a toString, and using one of the iFormatters there, you can do the same type thing with SQL Server using the same data types. So I have a link that will take you to the main page talking about the formatting types in .NET. And then on the left-hand side in the menu there, it'll show you like custom formatting for numbers, for strings, for date times, for that kind of stuff. So extremely useful and really easy to do stuff that used to really kind of stink in SQL Server.
Yeah, for sure. And Dance to Die's name in Slack today is Willie, the baddest dog of all. I don't know if you've seen the pic today, but it's my dog Willie looking like a smug little jerk like he's being tonight.
Oh, that's awesome.
Yeah, it's awesome. So that's very apt. And my recommendation today is for a brand new podcast. We were just talking about .NET Core a couple of weeks ago. I was talking with Boza, if you're out there, Original Boza, about .NET Core resources. And I said, hey, you got to follow this guy, Progman. He does a lot of writing about .NET Core, and maybe he's got something cooking you might be interested in. And the first episode has been released. So Jamie Progman has released the .NET Core podcast. He's starting that up, and he's a really prolific writer. He's got tons of material. He's been writing about .NET Core and has been kind of obsessed with it for a long time now. So if you are interested in .NET Core, then you have to go check us out. We'll have a link in the show notes there, and make sure you subscribe. And we've mentioned him a bunch of times too. He does us some other shows waffling tailors and whatnot, Dev Otaku that we mentioned. So, you know him, you love him. Got Prog Band. Check it out.
Yeah, dude's awesome. Please do. You know, I have no doubt this is going to be super high quality. I need to give it a listen.
Yeah, it's really good. First episode is on the history.net core, and he really does a really good job of going over like kind of how it came to be, differences between like ASP and .NET Core, and like different versions, and talks about CS Proj and the JSON. I mean, everything. Just really good.
Very nice.
So that's about it for tonight. Now we talked about Big O. We kind of wrapped up some stuff talking about you know, like time and space complexity and how much it really matters to developers. We gave some opinions and over under, and Outlaw had a great section here on kind of good and bad things that we struggle with.
Yep. So with that, subscribe to us on iTunes, Stitcher, and more using your favorite podcast app in case if somebody happened to point you into the direction of our show. And if you haven't already, please head to www.codingblocks.net/review, where you can find some helpful links there to leave us a review. We can't express how much we appreciate that, reading those reviews.
Definitely. Hey, and while you're up there, make sure you do check out our show notes. And if you're on your phone or anywhere, they make it over there as well. Our examples, our discussions, and more.
And send your feedback, questions, and rants to the Slack channel, which is codingblocks.slack.com. You can actually sign up for it at codingblocks.net/Slack. So make sure to follow us on Twitter too. You can ask us any questions or whatever. And head over to codingblocks.net where you can find our social links at the top of the page.